Good morning, fourth grade online learners. Welcome to February 22nd, 2021 science class. Today we were talking about chemical changes and we had a 2-hour delay. So I'm just going to sneak a quick video in for you guys so you know the topic of the week, and 3 journal entries this week with a quiz on Friday. And this week's lesson is based on chemical change. Chemical change. A chemical change produces new kinds of matter. Waffles for breakfast? If you've ever made batter for waffles, you know that it is a mixture that includes flour, sugar, oil, and eggs. Can you taste the eggs when you eat a waffle? Not usually. After you cook a waffle batter, it looks different from the way it looked before. The properties of the flour, sugar, oil, and eggs have also changed. That is why you cannot taste the eggs. Cooking waffle batter is not a physical change. It is a chemical change. A chemical change is a change in matter that produces new kinds of matter with different properties. Energy is always involved in a chemical change. It is either given off or taken in. When you make waffles, energy is taken in by the batter to produce a new kind of matter. And in this picture we see a chemical change of fire, changing that house for sure. So light and heat are given off to form different types of energy in a fire. Like physical changes, chemical changes involve particles of matter, atoms and molecules. In a chemical change, however, atoms and molecules do not simply rearrange. Molecules break apart and form new combinations with other atoms and molecules. The result is new matter with different properties. Atoms and molecules form these new combinations in a chemical reaction. A chemical reaction is another term for chemical change. In a chemical reaction, the matter that you start with is called the reactant. When you make waffles, the reactants include flour, sugar, oil, and eggs. The product of a chemical reaction is the newly formed matter. Waffles are the product when cooking waffle batter. Next page, we're going to talk about batteries. Common chemical changes. Every time you ride in a car, you depend on chemical changes. First, a chemical reaction in the battery produces electricity that starts the car. Then the car engine burns gasoline in a chemical reaction to produce energy that moves the car. The exhaust includes the products of burning gasoline. Chemical changes happen all around you. Burning wood, exploding fireworks, and rusting metal are chemical changes. Your body changes food in chemical reactions to give you the molecules and energy you need to grow. Clues that a chemical change is taking place include bubbles and changes in color, state, temperature, odor, and and energy. Thermal energy is the most common form of energy involved in chemical changes. Thermal energy can be added, such as when lighting a fire, or released, such as in an explosion. Other forms of energy involved in chemical changes include light, electricity, sound, and motion. The biggest clue to a chemical change is the formation of products that have properties different from those reactants. Again, we just show the battery here. On the next page, antacid and water. How does a chemical change occur? Atoms and molecules are held together by forces of attraction called chemical bonds. During a chemical reaction, the bonds that hold these particles together are broken. New bonds form between atoms, resulting in new molecules and new products. These new products have different properties from the reactants. This is because the products are made up of a different combination of atoms and molecules. Energy is often given off when a chemical reaction takes place. This release of energy can be very helpful when heating a house, starting a car, or lighting up a dark place. Sometimes this release of energy can be dangerous. An explosion can destroy buildings and injure people. Next page. Comparing physical and chemical changes. You have learned that matter can change physically and chemically. In a physical change, no new kind of matter is formed, although matter might look different. The chemical bonds between the particles of matter have not been broken. A chemical change always produces a new kind of matter. The new matter looks different and has different physical properties. This is because the chemical bonds between the particles of reactants have been broken and reformed. Compare the physical and chemical changes in the table. So we have some chemical and physical changes shown there. Ooh, this looks like a good page. Do you like toasted marshmallows best when they are soft and warm or browned and crunchy? Either way you like them, you probably know that it takes longer to toast marshmallows to a deep brown. It takes more heat from the fire, more energy, to brown a marshmallow than simply make it softer. It often takes more energy to cause a chemical change than to cause a physical change. It also takes energy to separate physical and chemical combinations. A physical combination is a mixture like sugar and water. A chemical combination, or chemical compound, is a combination of atoms that are held together by chemical bonds. Sugar is a chemical compound. To separate sugar water, you can allow the water to evaporate into the air. Energy from the sun causes the water to evaporate. To separate atoms in sugar, though, you must heat it to a very high temperature, hold enough to break the chemical bonds, high enough to break the chemical bonds between the three kinds of atoms that make up sugar. And the last page is a review page, and we will go over these questions tomorrow. So that's kind of a fast lesson on chemical and physical changes. We're going to expand on that with websites Tuesday, Wednesday, and Thursday, and have our website summaries. And finally, our quiz on Friday. Online learners, keep up the good work. Keep doing great on your quizzes, and keep up the good work on the journal entry. Some of my best work is coming from online learners recently. So you guys are getting a lot out of this and learning a lot. So keep up the great work, and we will continue to talk about chemical and physical changes throughout the week. We'll see you later. Bye-bye.